Great. So were you able to use Spark streaming? Did you try, Mandy? All right. All right. So you can try on the the Kafka part, because Kafka we do not have on the older machines. So Kafka streaming you can try on the newer Cloud Labs. Okay, the one h1.cloudx lab I was showing you yesterday. Okay, so in the video there is you can see the URL of the website as you know the passwords. I hope that you have kept the password safe for h1.cloudxlab and the login also. Alright, if you don't have, just let us know. I will send it to you in the email. Alright, so hello Jitender. Alright, so yesterday we gave a demonstration on how to use Kafka for Spark, Kafka and Spark integration to do the stream processing, right? All right. So if you notice in this code, if you notice closely here, the important part you should notice is that this particular logic after, yes, here, this particular logic automatically keep getting repeated again and again on every batch. How is that happening? There is no while loop here. Okay, this is not inside a loop and still it's getting called every second. Okay, the magic is done by this kvs. This this kvs is not a standard RDD, instead it's a streaming RDD. So every time you define a function on kvs, this map is a map provided by streaming engine. Okay, this map is provided by streaming API, and whenever you are defining a map, you are basically telling the streaming that hey, we have just defined a map on this. And then again, this line is again an streaming RDD. So any function which you define on flat map is again going to call streaming RDD, and thereby counts is also streaming RDD parts, and so on. And when you say count.pprint, you are actually calling the pprint function of an RDD. And as soon as you start kvs dot as soon as you start kvs sorry as soon as you start ssc here, because on the top of ssc you are creating kvs. So when you start ssc, it makes a note of all the map functions and all the functions that have been called on the all the functions that have been called on the ssc, and thereby computes which all functions need to be executed again and again. Therefore, if you put a method something like here, if you put a method something like print counts dot collect, okay, or lines.collect. If you put something like this, it will get executed only once. It will not run every second. Okay, you can try that. All right. Yesterday, when we were doing it, all of these functions were getting executed every second because we have created a streaming context which was running every second. All right. Now let's understand what are the functions streaming streaming API. The map, flat map, and filter is a usual function provided by dstream, and repartition again is same as the core one. Count and union is the usual one. Reduce and count by value is also the usual one, the one which we discussed about the normal RDDs. Now, reduce by key is also known to us. Okay, you can use join to join 2D streams and such that the two streams will be joined together based on the key. Okay, so if your D stream is made up of key and values, you can join the two together and you will have something of this sort. All right. Now the last one is co-group and transform and update state by key. Now the last two are something important and we would like to understand these. Co-group is okay. Co-group is okay because I think we have already studied co-group. So when we are calling co-group on a D stream of key value, say one D stream is KV and other D stream is KW. We are calling on KV dot co-group and giving the KW one. It will return a D stream of all the sequence V, comma sequence W. What does it mean? So first it will group all the values in the first stream by the key, and then it'll group all the values for the k in the second one, and then group all of them together. Okay, so co-group is equivalent to grouping, uh, joining after grouping. All right, we have already discussed this part. Now transform is return a new D stream by applying RDD to RDD function to every RDD of the source stream. So basically transform is something important which we should know. So it's a general function to apply on our stream. Okay, it's a general function and it's an action basically. All right, so whenever you want to do something on a D stream, say you want to print every element of a D stream, you use transform. You can write your print function inside the transform and hand it over to the transform. Now update state by key is something which is very different from what we have read in past. Okay, now so it update state by key and we pass a function to it. All right, and the function which we are passing here, it will get two things. One is the running count and other is the current state. All right. So it basically applies this function on every element. Okay. So it will take your function and it will apply on every element in this RDD, and it will maintain a state for each key. All right. So if something unique has to be done on each key, that can be done using the update by key function. Okay. Here is the example. So update by key operation allows you to maintain arbitrary state while continuously updating it to the new information. Okay. All right. So basically, it is sequentially applying a particular function on on all the keys. So it is equivalent of grouping all the keys together, and then it is equivalent of grouping all the keys together and then monotonously going over the values of these keys. Okay, and doing some operation. But again, if the values are too many for a key, then this approach might overflow, because when you group by key, the values will suddenly come together and each object might be really big, right? Therefore sometimes this function solves your problem. you can say you can say update by key and let this function be called with this update object for each of the keys. Okay, and let this function update the object for each key. Okay, so you can think of it that Spark is maintaining a really huge hash table of keys and the states, and every time it encounters so when you are saying update by key, it will pick up the first object from the RDD. It will pick up the first object from the RDD and find out the state from its big hash table for this particular key, and then apply the function providing the state. Okay, similarly, for the next object in the RDD, it will again figure out the state from the store, and then it will do the magic. Okay, so that's how update state by key works. So for example, word in case of word count, the state will be the number of words that have been encountered. Okay, that will be the state, and internally the states for all the keys will be maintained by Spark, and thereby you can apply update by key to count the total number of unique keys. All right, that is the purpose. So you can see here we have update function, we have new values and running count. Okay, if running count is none, we initialize running count with 0. Okay, and and basically sum up the new values with the running count, and that's how it returns the new running count. Okay, so this is the count, this is the total count which we had. So every time a key is going to get encountered, that running count is going to be available here. All right, so basically it is like usual usual word count problem, where every time we encounter a word, we look it up in our dictionary, and whatever is its state, we increase it by 1. So instead of you putting the for loop, okay, you only take care of update function. Okay, internally every time and for each RDD in this whole for each RDD, for each element of RDD, first it will retrieve the current running count based on the key and then apply this function, and whatever is the result of this update count, it will save in that hash table internally. All right. The transformation operation is applies arbitrary RDD to RDD function on a D stream and applies any RDD operation that is not exposed in the D stream API. Okay, let's say let's say you want to do the real-time cleaning by joining the input data stream with pre-computed spam information and filter based on it. Okay, so you can simply load the data. Okay, and all right, so yeah, so here what exactly are we doing is we have word count which we need to transform, and this is the function using which we are transforming our word counts. All right, now here this function takes an argument called RDD and then performs the join operation on it. Okay, so sometimes you have to operate upon the RDD which is underlying your D stream. Okay, so as we told earlier that D stream is composed of many RDDs and each RDD has got elements. So if you want to apply certain operation on the whole RDD, then transform is the way to go. All right, transform is the way to go, and here that's what is happening. So given an RDD, there we have two RDDs. One we have loaded already for joining, and other we are applying here. Okay, so this is the raw function. You remember the way we have ASM code in our C language so that we could call the basic one. Similarly, dstream exposes the RDD through the transform function. Okay, so dstream underlying contains the RDD. Every time for each batch it computes the new RDD, and then it runs your code on this particular newly freshly created RDD. As and when new data keeps coming, it keeps creating new RDDs and keep executing your various translations using on this newly freshly created RDD. Okay, so when the data comes in, it creates a new RDD, and on this newly created RDD, it will apply your flat map, map, flat map, and filter and whatnot. Now, sometimes you want to do some operation before these streaming operations are happening. You want to operate on the underlying RDD. In those cases, you use the function called transform. All right, the function called transform. This transform will transform the RDD, and it will give you a handle to the underlying RDD on which you can do your usual RDD operation such as rdd.join. Okay, so this is a good way of handling things. This is a good way of computation when there is no alternative. Let's say there is a function, there is particular function you wanted and is not there provided by dstream. In those cases, a transform operation is quite useful. All right, now Windows operation, we have already covered a bit of it. So there are two things here. There is an original stream, D stream, and this is a Windows D stream. So when the data is coming in, we create, this is the D stream. We can further create window over a D stream. Although the D stream itself is sort of a window. Okay, so sometimes it makes sense to further group the items time wise into the windows. Okay, sometimes you want to basically minify the data into the windows. Let's say instead of a window of 1 second, you want to visualize the data into hourly basis. Or sometimes instead of visualizing the data in, if you have got a lot of data which has come in or you've just loaded, you don't want to visualize or process the data, uh, visualize the data per second basis, per millisecond basis. You instead want to visualize it on per minute basis. In those cases you can create the windows. There are two things you can do specify. One is the duration of the window. The duration of the window, as we have three in this, meaning how big is the window going to be. All right, and the sliding interval. Okay, the interval at which the window operation is performed. Here, if you do not have a sliding interval equal to the window size, what would happen is there would be an overlap. Whatever is the difference between the window length and sliding interval, that will be the overlap. Okay, so the item number, the element number time 3 will be processed twice. All right, these two parameters must be multiples of the batch intervals of the source D stream. All right, now keep that in mind that whenever, so yeah, because if you remember when we were creating the Spark stream itself, that Spark stream was itself the Spark stream itself was operated on certain time period. Okay, so if you are saying that if let's say the Spark streaming context has been created on every 3 seconds. Now, the window length and sliding interval both have to be multiple of 3 seconds, because the smallest element that is possible in case of a window operation is 3. Therefore, your window length has to be maybe 6, or maybe uh, okay. So when you say 6, that means there are two elements which you are going to consume. The two elements that have been consumed, that have been created as part of the uh, created by the SSE. All right. So essentially, whenever you are creating the window operations, the window length and the sliding interval both have to be multiple of the original the batch size. Okay, the time period. All right, so for example, if you have to reduce last 30 seconds of data every 10 seconds. Okay, so if you want to summarize the last 30 seconds of data and you want to do it every 10 seconds, okay, which means 20 seconds of data is going to be computed again and again. All right, So in those cases, you can use a function like you have got pairs of words dot reduce by key and the window size. You provide your reduce function, and then you provide 30 comma 10. All right, there are similar to our other reduce functions. There are the functions related to the window operations, such as window, count by window, and reduce by window, and reduce by key and the window, reduce by key and the window, and you provide number of tasks as well. All right. And the inversion function, you remember the zero function, those kind of functions you can specify, and count by value and window. All right, so these are extensions. These are further grouping based on the window elements. All right, you can join two streams. If you have created two streams using SSE, you can join the two streams. Okay. And similarly, you can also join the windowed stream. So creating a window on an existing stream is basically going one step further and further grouping the things based on the timeline. All right. So similar to left join, right join, you can do right outer join, right left outer join, and full outer join. Okay. Normal join is inner join. And also on the Windows stream, you can execute transform. All right, there are few more functions which are provided by the Spark streaming context. One is print. So, so you have to say element.print or rdd.print. It basically prints only first 10 elements. Okay. So you can say if you are using Python, then you will have to use another function called pprint. You can save as text file whatever rdd stream rdd that's going to get created, that gets saved as text file, save as object file, and save as Hadoop file, the usual functions provided in the normal rdd. All right, now there is something called for each rdd. Now if you have a function which you want to execute on the whole rdd, then inside the d streams, okay, then you should use this function. Okay, specifically if you want to print the data, you can create your own function. It basically applies this function to each rdd generated from the stream, and it should push the data to each rdd to an external system. All right, now keep these kind of things in mind. So whenever you are saying dstream dot for each rdd and you are sending your function, this function is creating a connection object. Do you see that? All right, so this function is get creating this connection object, and we are creating this object, and inside our for each we are using this connection, which means this connection object gets shipped to the all element to the cluster elements who are going to execute this rdd. This Since this function will get shipped, okay, this connection object will go with them, and and hence it will be an error. Okay, while we have closed the connection, they will try to execute this. All right, so this connection object is always about the local machine. It's not about a universal object. So connection object generally cannot be serialized and moved around. Okay, ideally you should be creating the connection object inside here, not outside. All right, therefore in this case this is the right way of using it, where you create a connection object. No, actually, no, this is wrong. No, this is wrong. This is wrong. Okay. Instead, because this is not correct. All right. Instead, what it should do is here itself, here itself, what it should do is it should iterate over here, and then it should say send record. All right. And then say RDD. And underneath, okay, underneath, so here is an record, which is basically we are picking up every element for each RDD, and then we do things. All right. So yes, something of this sort, and we say connection dot send, and we say record. This is correct, because here what we have done is creating the connection, we have left it for the local object. So these are the common problems which you will see in your code going forward. All right, because you keep on assuming that this function is local, but when you try to send it to the cluster, then you realize, oh, it's not really running on a machine, it's running on the multiple machines parallelly. All right, so keep these kind of problems, keep your eyes open for these kind of problems. All right, is this problem clear to everyone? Do you understand the difference between this and this? Gaurav, Jitender, Mehdi? No? All right, so I'll just go over this once more. So let's say we were talking about a function called RDD. Okay, so after the D stream has finished, after we have finished working with our stream, sometimes we want to do some extra operation rather than only print. Okay, so what do we do with, question is, what do we do with the results of our streaming operation? We need to either save them, or we need to print them, or do some extra operation on the resultant RDD of D stream. right? So in those cases, if you really want a custom one, you can use for each RDD. It applies the function to each RDD generated from the stream. Okay, what does it mean to me? It means that whenever an RDD is created, on small batches, on every small batches, we keep on creating an RDD. Say for example, we are saying Spark streaming context 1 second, and for 1 second, whatever elements are there, it will put them into an RDD and hand it over to you. This way, the stream is made up of many RDDs. Okay, and as soon as the work is over, that RDD is deleted from the system. Okay, so that's what keeps on happening all the time, right? Now, there are few mistakes which we do. For example, here, what we are doing is once our work got over, we want to send the elements of an RDD over over the connection. Okay, over some network connection, or we want to save it in database or whatever. For that, we thought we will just try to cache, we'll just try to per, create a connection only once for each RDD and then utilize it. All right, that's what we try to do here. We thought that we will use this connection object only once and then do something. Okay, but the problem is the for each itself RDD, so it's an element of elements. So your function, this send record, is getting executed on the list of elements. And inside the list of element, when you say for each, it again gets executed on other different nodes. Okay, so you created connection object on one machine, it got transferred on another machine, and that's where the problems start happening. Okay, is it clear, Mehndi? It's better now? All right. Do I make sense now? Do you see the difference between this and this? Here we are creating the connection on the machine which is the last. Or what you could have done is, if you wanted, you could have said things like elements equals to rdd.collect and gathered all the object on this machine, and then you could have applied a for each and then send it over the connection. Okay, but right now when you try to pass the connection object in the function you are handing over to for each, this function will go over to other machines, this function will go to other machine, and hence it will take the connection object to with it. Okay, and effectively, since connection object has been moved to another machine, it is no longer valid. The connection object means that I am this machine, I am connecting to that machine, and in case a request comes backward from ping, I'll say that yes, it is me. So connection object is very stateful. It cannot be moved serialized. Make sense to you? Sometimes while trying to do the caching on the connection, this is the thing which we do. Instead, use another ways of a centralized way of caching the connection, or totally avoid caching the connections. Yeah, does it make sense now? All right. So that was our detailed discussion on Spark streaming. We were able to do a rudimentary plain text word count by by reading the data from a TCP stream, reading the data from a server. Okay, as well as we were able to do do the Spark streaming while reading the data from Kafka queue. And the other operation, how to extend the operations on various D streams, is what we discussed today. All right. Using transform and using for each, you can do many more operations together. Right? Good. I'm happy, Gaurav, that it's clear to you. All right. Any questions on streaming so far? Has anybody tried to run the streaming? Anyone? Okay. So try doing it today or tomorrow, because the more you delay, the more it will keep on getting lagged. Maybe the infrastructure, which is Cloud Labs, might move, and therefore the steps which we discussed today will not exactly apply. Maybe there will be a little variation. Okay, so make sure that you try it right away, so that you do not have any more surprises. Okay. So the video recording is available of yesterday. In case you want to go back and take a look on exact steps which I took, you please go through it. Okay, I strongly recommend that you try at least one of the streaming. Okay, I will prefer that you go with Kafka. Okay, and understand each and every step you execute, and rest will I mean you can take care of. All right, you will actually understand the things only when you do the hands on. All right, great. So that was our discussion on the remaining discussion on the Spark streaming. We will now move on to another interesting topic called Spark SQL and data frames. All right, so after we launched the course, the data frame has become very popular and have become very stable. Okay, when we started building the plan in the beginning, the data frames were not in the shape of shipping. So that essentially shows that the Spark has been changing very often. All right, it has been improved very often. All right, so we will go into the details of Spark SQL and data frames, and we'll talk about things. Generally, if you today you will find that most of the Spark library are broken into two parts, one in the form of RDD and other in the form of data frames. Okay, we will talk about these two differences, and it is very important to think about the two. All right. So Spark SQL is the Spark's module for structured data processing. The structured data processing means that we know the structure of our data. And structured data generally refers to the data in tabular form, which has got fixed number of columns and which has got rows, and each column has got data type. All the values in a column has got same data type. Okay, so that kind of data is generally referred to as structured data. Spark SQL provides a programming model called data frames. All right, on top of RDD, the RDD was more like an array in which there was no structure. No structure because one element could be an integer, other element could be a complex object, and next element could be a string. If you don't believe me, you can try doing it right away. Okay, you can try doing it. All right, I'll show you this. Now you can have a look at it. So Let's say you have an array which has first as a string, second as float, third as integer, and fourth as a complex object, something of this sort. All right. So you have this complex array. There are different data types inside this array. All right. Now, if you say ARDD is the name of new RDD which we are trying to create, we say sc dot parallelize and we say A. So our ARDD is happily created over disparate type of data. Do you see the difference? So if you say ARDD.collect, you will get what you're looking for. See that? It's exactly same what we have put. So it does no validation, no transformation, and thereby the usual RDD is not really structured data. All right. So, and that's why the idea of data frame comes into play. Spark SQL can act like a distributed SQL query engine and can be used to read data from existing Hive installation. Okay, it can act as a distributed SQL engine and can be used to read data from existing Hive installation. Okay, we will go into the details how to do it exactly. So there are two things which we are talking. One is it can behave like a distributed SQL engine. Other is it can utilize Hive installation to do the same thing. All right. Now, the entry point into all the relational functionality in Spark is a class called SQL context class. You can create an SQL context or you can subclass it. Okay, so that will be your SQL context will be the entry point to the whole world of Spark SQL. So what happened to all right. Okay, so we can start with creating our Spark context. We can create our own SQL context as well. So you can see that. So we are creating an SQL context here. Although the same word was available as Hive context, you can create that again. Now there are the SQL dialects is an SQL which is very simple. Okay. It's the SQL dialect which is provided by SQL context is very simple and you can apply that SQL on a data frame. Data frame as a concept is very similar to database table. And the word comes from R. Now, there is another class called Hive context. Whenever you want to connect Hive, you use Hive context. Hive context is basically an extension of SQL context. Hive context is essentially an extension of SQL context when you want to interact with Hive. And Hive context uses HiveQL because it will be querying Hive for your needs. Okay, it needs to whenever you are using Hive context, you need to have an existing Hive setup, and all of the data sources which are available to SQL context are also available in Hive context, because Hive context is basically an extension of SQL context. Hive context is packaged separately. You need to use a different package because it is not bundled with the core one. Now, SQL dialect is, in case of Hive context, is HiveQL, which is far more complete than our basic SQL context. So there are two advantages with Hive context. One, since it's going to execute the query on Hive, so HiveQL will be used, which has been the Hive per se has matured quite some time. Okay, so for querying in the local data in our local way, it is good to have Hive context, sorry, SQL context. But in case you already have Hive installed and you want to do the data churning on Hive, you use Hive context. All right, now coming back to our idea called data frames, that is a new idea uh, which we need to understand. Now, data frames are a collection of data organized into name columns. All right. So we define the name of the column along with their types, and give it and force this structure on RDD, and that's what is called a data frame. All right. So in case of data frame, you can imagine it as if an RDD composed of elements, which is a row. A row is a single element in the RDD. Okay. So a data frame is essentially equivalent of table in relational database. A data frame in R or Python is also equivalent of the same. So in Python and R, there has been always a data frame which is being utilized for quite some time. In R, the whole idea about computing is built around data frame. You can create a data frame using structured data file, tables in Hive, external databases, existing RDDs. Okay, and data frame API is available in all languages, whether Scala, whether we are going to use Python, Java, or R. The data frame object is available in all these languages. All right. Now let's have a look at it. How to create the data frame. The simplest one is using the SQL context. Applications can create data frames from an RDD, from Hive, from other uh, data sources. Let's try to create it. So let's say you have a file, this particular file. I have copied this data in slash data in Spark. I have also kept it locally here. So let's go to Asgiri and we say, not this one, what was that class name? Spark. All right. So we have people.json, and let's see what is there in people.json. And this data is available locally. All right. So you can see that. Let's run PySpark. Generally a good idea is to have, not this, to have, I'm just adding Spark into path so that I don't have to put absolute location. Okay. When I say PySpark, it will find it in the path itself. All right. Now we can load this data. So first, as we told you, that you need to import SQL context, then create an SQL context object from SC, and next is that you can do SQL context dot read dot JSON. Okay, so this is the way you create your first data frame. This is our data frame. It says data frame. It has got two columns. One is age and other is name. Age is a big int and name is a string. Now on top of this data frame, there are many operations that you can do, right? That you can do. All right. So if you access things like this, it'll give you that particular column. All right. Now if you want a particular row, you can say is equal to or df dot show. Okay, you can see that. So you can say is equals to 30. All right. All right, we will show you more. Okay, I'm also a little new to data frame ideas, although I have done it in R. All right, so we are able to load the data the from the JSON happily. This particular JSON object was successfully loaded as the data. Now it basically tries to consider it is at a single level object. If it has multiple objects, then the situation is going to be different. All right. Now further, we could see the schema of a data frame in this way. And then if you just want to see one column, yeah, select is the one. So we could say df dot select, and we say age equals to 30. Okay. All right. A bit of disconnectivity would happen. Are you able to hear me clearly? Jitendra, Mehdi, Gaurav? All right. Are you able to hear me now? All right. All right. Because there was a disconnectivity for a few seconds. All right. So we were showing you this part. Let me see if let me go to the same folder. Also, it is available. All of this data is available in fs dash here, here at this location STFS called slash data slash spark. You can go from the hue as well and have a look at this data. Okay. So I've just copied it locally. Also, you can copy it locally if you want to operate on it. All right. Let me start PySpark. Since I've added the PySpark bin folder into my path, I don't have to provide the absolute location. All right. Now coming back to loading the data, we'll have to do it again. And then we'll have to print the scheme. We have already done that. See that? If we want if we want the another column, we can show that column as well. See that? Yeah. So this is how you can operate on a data frame, as well as you can join multiple data frame together and get the results. Right. So every time we are slicing it, it's producing a new data frame. Okay. All right. Next is that you can similarly select the columns and provide the operation, something like df.age. Here we are increasing it by 1, just like we did it earlier. We can do, I mean, just like in SQL, we could say df age and plus 1, and that's what it will lead to, and it will give us the results. Similarly, we can filter df based on a condition like this. All right. So we can filter the data in this manner. You can see. All right. And you can also group by, okay, and then call the counts. So group by and then call the function on the data frame. All right. So this is how you can operate upon data frame. Now, sometimes you want to run a query on, you want to load the data frame using SQL. That you can do. Okay, you can say things like df equals to SQL context.sql and provide this query. Now, what does it do? It basically queries a table. And what is this table? Table is created by SQL context. This table can refer to a table which is in the database, or it could be referring to another data frame. I will show you how to use a data frame like a table and then query. Okay. Now let's first talk about how to create a data frame. There are two ways of converting an existing RDD into data frame. One is One is by going through record by record and creating the rows and creating the data frame. Second is programmatically specifying the schema. You will see the difference when I show you the code. All right. So for example, here, let's take a case of this particular file called people.txt. All right. So let's take a case of this people.txt. We have, let me press Control Z and scat people.txt. Okay. FG is to bring it back into the foreground. All right. So we have people.txt. SQL can convert an RDD to. So using Spark SQL, we will convert an existing RDD of row objects to a data frame easily. But first we need to convert our existing RDD into row objects. Each element we need to translate it into a row object. And then we can go ahead and create data frames. And rows can be constructed by providing the keyword dictionary arguments. Okay, let's try to convert this into our data frame. All right, going back. So here what we did was we just simply said read JSON and it read the data into JSON format. Now we are trying to create first an RDD just like this one. So first we said load our lines. Okay, if we say lines.collect, we are going to get all of the data. So this is what it is. By default, it's loaded as this is one line, this is another, and this is another. Okay, so these are basically three strings. We want to first split them into the parts, right? Now if you see what does parts have, parts will have six elements, not six element, but three elements with array, each element to be an array. All right, now next thing what we can do is we can again map, and we can create something called row object and put it there in the RDD. Okay, you can see people.collect, and now it will show that each object is a row object. Now row need to be defined. All right, row need to be defined first, and row is defined as import row. All right, yeah, this is good. So all we needed was we had to include this, which we forgot. All right, let's just include this. Okay, so we have included everything from PySpark, and now we are trying to say what was that? People equals to part.map. Now people.collect, you can see that is basically a row object. So we basically converted strings into a row object, and keep these strategies in mind because those will help you a lot. Now you can create Now, once you have row objects inside your RDD, you can create data frame directly by saying things like this. Okay. So when you say create data frame, that will automatically create the data frame. You can see that the data frame is here. So we were able to successfully convert our raw data into an RDD and an RDD into the data frame by first converting each element into a row. Okay. Now, once you have created a data frame, the next thing which is important is if you are obsessed with SQL and you don't like data frame way of doing things, you can register this data frame as a table. Okay, you can register this people this particular uh, data frame as a table, and then once you have registered, then you can make SQL calls like this. Okay, like this. So if you are comfortable with data frames, keep doing that. Okay, keep using your usual data frame. Otherwise, you can also use SQL interchangeably. So we just use SQL over our data frame, which gave us another data frame. All right. Next is that in case we want to apply on a data frame, the usual map and reduce methods are all applicable. So for example, here teenager.map, and we are passing a function which is basically converting name into prefixing the name with name. Okay. And then we can say, so let's see, and let's try to collect it. What happens? Now you can see that name equals to Justin. Why? Because that's what we selected as part of A is greater than 13. And A is greater than 13 means, yeah, A is greater than 13 and A is lesser than 19. Less than or equal to 19 is Justin only. Okay, so I hope this is clear to everyone. So we did many things during this exercise. First thing we did was we converted plain text into an RDD by using our usual text file, and then we converted each element into row object, and then we created a data frame on this RDD containing row objects, and then we registered a data frame as SQL table and queried that using SQL context.sql. Now once that query executes, it will produce another data frame which we can operate on. So there are two ways to operate on data frames. One is usual data frame operations, which has its own syntax and is quite popular amongst people from R background or people from Python NumPy background. Okay, so you could use these two things interchangeably. There is one query language for data frames, okay, which is something like data frame dot select, then dot group by dot filter, and the other is usual SQL kind of operations. Sounds good? So what is the difference between R and Spark? Thank you very much for this question. I was planning to. All right. Thank you. Thank you for this question. And let me just start creating notes. All right. Keep the questions coming. All right. So what exactly is difference between between data frame in R and Spark? Okay. Any guess? Anybody? All right. So the biggest difference in R and Spark is that every data frame in R is loaded into the memory. Okay, data frame in R is all in memory. Okay, so you could only load limited amount of data in the memory. Okay, now in case of Spark, uh, there are two things. One, data frame is basically a representation and not really a data. Not really data, but RDD representation. The actual data frame is actually computed, and it would contain some data only during collect actions, when we say df.collect or something like that. Second, even during that time, even during an action, when we are doing an action or we are persisting an action, df is distributed, which means a data frame is loaded on multiple machines and thus utilizing their RAM. If you are from our background, you can connect at this point of time that in R, the biggest challenge people faced was how much memory can you handle, and that was a very big challenge. In R, you could not go beyond what could be handled in the memory. Therefore, you were always limited by the memory available on the computer. Alright? So theoretically, all the functions which are there on a data frame are also available in Spark, just that there are internal differences. Gaurav's question is data frame API like Java persistent, this JPA? So it is kind of, the API looks like that. All right. Now the other way to create a data frame is by inferring the schema using reflection. It's not correct. Inferring the schema using reflection. Inferring the schema using reflection. This is programmatically specifying the schema. All right. So earlier we were happy that we were able to create the full structure of the row before before creating the data, right? Sometimes that's not possible. Sometimes you don't have that information upfront available. In those cases, you can create schema represented by struct type matching the structure of tuples or list in RDD as in created earlier. Let's try to do that. Okay, let's try to do it. Okay, so what you do is first you create something called fields. Okay, So you first said name and age are the two fields we are going to go, and then we iterated over the list of fields and then created this structure. So we are saying we have got a struct field with the field name and and a string type, and which of string type, and third is true. True means can be blank. I think true means can be blank. So for each of name as well as age, we are creating the field name and string type. And we say that our fields equal to this and schema equals to struct type, and then we provide the fields. Okay, so this will create a schema that represents these two columns. Both are going to be of type string for now. Okay, or let me make it a little more simpler what it leads to, because you may not be very comfortable with this for loop, and that I know. So it would look like this. It'll look like this. It'll say name, okay, and string type is good, then comma, and then again another field. And here it is going to be age. See that? So we could create the fields like this and also schema on top of fields. So we can see that we have just created a schema like this. All right. Now, if you have to do, if now we can impose. All right. Now we can impose this on our data frame. All right. Now the schema people, if you see, it is a data frame containing. So we already had a people this RDD. You can see that people is an RDD. And no, actually, we should have done it this way. All right. So people is an RDD now. Yes. And then we can apply this schema people. All right. All right. All I did was I did all the steps again. So once we have created this people, let's see what is there in the people. People is an RDD. And if you say collect, then you will know what is there inside it. So it basically is an RDD where every element has got two values. Both are string. One is both are strings. So Justin as well as this number both are strings. Now, the moment we impose the schema, okay, and we try to say this dot show schema, print schema, sorry. Now you can see that both are strings and have been loaded. Now, in case, let's try to, okay, all right. So this way you can impose a schema on RDD and convert that into data frame. And then you can do whatever you want. You can register it as a temp table and run the SQL on top of this. So whatever name you provide here, let's say people123. Okay, let's say you are providing the name called people123, then you can use people123 here, all right, and gather the results. Okay, you can say show. See that? So whatever name you are using here to register as a table, the same name will be available in the SQL that you execute on top of using SQL context. So this table is made available to SQL context using that name, and then you can do that. Now, the important part here is that you could have these tables either from data frame or from other mechanisms. And then you can start joining the table using select queries. All right. Now you can collect this data and then you can collect this data and print it. Sounds interesting? Now moving ahead. So we talked about few things today. We talked about what exactly is data frame. We talked about two things. One is SQL context and other is Hive context. All right. Now, we talked about two ways of querying the data. One is using SQL, other is using the intersections from on data frames, and basically projections on data frames. So the data frame as an idea is very great, and that is the reason today on top of Spark, people not only use Python, Scala, and Java, people also use R. So R has been successfully ported onto Spark. The reason is that we have data frame representation. Okay, so it's important to understand that because of having ideas like data frame or because of ideas like RDD is kind of unstructured data because one element in RDD has no relation or no constraint as the second element, while in case of data frame all the elements in the RDD have to be of the same type. All right. Spark SQL supports operating on variety of data sources through the data frame interface. So, so you can create data frame using multitude of data sources, be it JSON, be it XML, be it plain text, be it a normal JDBC connectivity, or be it a Hive. So we could create data frame from all these sources and then do various kinds of operations on these data frames. All right. A data frame can be operated as a normal RDD and can also be registered as a temporary table. The other use of data frame other than calling df.filter or df.select, the other use is we can use the data frame as if it's an RDD. We could do map and we could do reduce on top of data frame. All right. So you can have a look at all the functions provided to you on results. Okay. Whenever you want to have a look at what are the functions provided to you on this, you can see that it has got flat map, it has got filter, it has got for each, it has got all the things which we had earlier used on an RDD. All right. So as an abstract concept, so the way RDD served for unstructured data, for all sorts of data frame serves as the data frame serves to all the structured needs in which each object has got data types. Each object has got each object is a row containing many columns, and every column has got a name. All right, so that is the difference. Also, in case of data frame, the values are of the same data types. So those are the two differences, and that's the difference between normal plain text file, normal array, and a database table. Okay. The way when we say that a table is an array of rows in which every row has the same structure. In the same way, we call that data frame is an RDD in which every element has got the same structure. All right. Now, data frame can be operated like a table using Spark context.sql, and and also we can basically we can load data from many sources using onto the data frame. All right. So there are three things or three ways of operating on data frame. First, using the R way, in which we can do select, filter, and others. Second, uh, using the SQL by registering as a temp table. Third, behaving as if a data frame is just an RDD, using using on top of it map and reduce. All right. So there are these few data sources which we'll go into. So the default one is parakeet. If you don't specify the format in which you are loading the data, it is considered as the uh, the it is considered as parakeet file. Or instead of saying read.load, we could say read.json. The way we said earlier, the way when we were loading the data here, we said read.json. Okay, so you can have a look at the all the functions provided by okay all the functions provided by SQL context dot read. Okay, we can say dir. All right, so you can read the data from JDBC. You can read the data from JSON. You can read the data using general load function. You can read data using SQL context.read.parakeet, and and you can also read data using SQL context.read.table. All right. So there are many ways to read the data into Spark into data frames. All right. If you have got a parakeet file, you can simply load it. And then once you have loaded it, then you can either call like this or register this data frame like a table and then apply. All right. And then you can save the data like this. If you do not provide any format, it will be saved as a parakeet file. Parakeet is similar to any other format. Parakeet is also one of the formats in which that was designed by default for data frames. Okay, but there are many formats in which you can interchange the information. All right. Next is that parakeet. Also, those who are not aware about parakeet is a column way of saving the data. So whenever you want to store structured data which has consistent column definitions, then you generally use parakeet. The quality of a parakeet is all the values in the columns are stored first. Okay. So So if you have a file which has 3 columns and 20 rows, first when we try to serialize, all the values of first column will be saved, then second column and third column. Okay, it has nothing to do with the logical representation. It is the underlying data, underlying structure, how it is saved. Okay, and generally in case of big data, the it has been observed that if you compress all the values of columns to of a column together, it's more compressed, because in case of structured data, all the values of a column are of same data type, and most likely they are going to be similar, more similar. Therefore, if you compress all the values of one column together, is going to be far more compressed. Okay, imagine one column containing only true and false, that too as a string. If you compress it together, it will be very small, right? That is why a parakeet is a really good one, good compression. Similarly, if you have the a column that represents the marks of people out of 100. Now, if you try to compress it, these are only 100 numbers which are going to be repeated, and therefore the compression algorithm will work really better. So, the general discussion here is why columnar format are good and for structured data. All right. Now, sometimes you can, while saying load, you can say format equals to JSON and it will load it as JSON. And while saving, we could explicitly say that please save it like a parakeet. All right. So if you are using a Hive context, not SQL context, then data frame can be used, saved into persistent tables, like a real table in the database. All right. So let's take a break, a quick break, and come back. All right, I'm back. Should we start now? Gaurav, Mehdi, Iswar, Jitender. All right. Is my voice clearly audible to you? Great. So before the break, we talked about SQL context and how does SQL context help us to query data as data frame, and then how to convert an RDD into data frame, how to load the data as a data frame, and so on. All right. So most of the communication in SQL context happens over the data frame. Temporarily, if you want to use SQL over data frame, you can use the SQL. This SQL is not the standard SQL. This is a small subset of SQL provided with SQL context to query the various data frames and the various tables that we create using SQL context. All right, great. So the next part is Hive tables. Spark SQL, which is composed of two things, which is SQL context and Hive context. Okay, so Spark SQL supports reading and writing data stored in Apache Hive. Okay, so you can query Hive using Spark SQL. And since Hive has a large number of dependency, the Hive context is no longer included in the core Spark. Now you have to build Spark separately for Hive using phive or phive thrift server flags to Spark build and then use it. So generally, a good practice is for now that you build it with Hive, and by default, up to the last version, it was included in the in it was included. From this version onwards, Hive tables have been separated out. All right. Configuration of Hive is done by placing your hive-site.xml in conf folder. All right. So we have already done this job. In yarn cluster, in the yarn cluster mode, if you remember our yarn cluster mode in which driver also execute inside the yarn nodes. Okay. Inside what do you call the node manager. Okay. When your driver is also executed by yarn, that is called yarn cluster. Okay, the data nucleus jars under the lib managed /jar directory, and so basically you just need to keep all the jars and hivesite.xml in the conf folder, and that need to be made available on all the nodes at the same location. Generally, this can be very well done by using the jars can be shipped to all the nodes by dash dash jar, and hive dash site.xml is shipped using minus minus file option of Spark submit command. All right, so you can ship these two and make it work. All right, we will take few examples to work on it. All right, let's try to see what happens in case of. So we will take one more example after this. Yeah. So Spark context is an existing Spark context. We know that, and then we are saying pyspark.sql, and we are importing only Hive context from pyspark.sql. Okay. Next is that we have created SQL context. It's basically Hive context. I think let's not confuse it. Okay, let it be. Okay. So under the hood, SQL context is based on this object. All right. If we create SQL context using, say, SQL context here. If you say SQL context, then you can see it's a different object now. All right. So going back, now this is our Hive context basically, and on top of it, we can say things like create table. Now let's first check if this is working or not. Okay, let's see we do this. All right, it's trying to connect our Hive and is trying to store the data there. All right, let me open another terminal and again do the SSH. Do the SSH. What does it say? It says that there is no user slash Hive is not a directory and is not able to create one such directory. And why is it failing to do so? Let me just try to see. So we are saying Hadoop fs minus ls user. Okay, what's happening with this? Alright, it says that it's not there. Alright. Alright, just a second. Give me a minute. We will go back a couple of steps. So first we need to copy etc hive conf folder into the current folder. That's what we did right last time. When we were loading data in from Hive, this is what we did earlier. Yeah, this is what we did earlier. And so, okay. All right. Also, we'll just copy. Will it work? PySpark. It says rows is not defined. And what happened to this? No such table called employee. is such table exists. Does such table exist? Or did we delete such table? Alright, let's try to see show databases. Use default, show tables, and do we have a table with the name employee? Yes, it did. So we can we say select star from employee? We are talking in Hive right now. Okay, so that's what we are trying to do. And let's see, going back to this, select star from employee. Okay, let's try to run it again. It's not able to connect. It's not able to connect. Alright, no, it's actually not connecting to the Hive. We will have to copy the entire folder. Let's just go to the home folder, and we have here, and under this conf we have already, so this is the conf folder we have, and this is our Hive site.xml. Now we can go back and then start PySpark. We are starting PySpark from the folder which contains the entire conf folder. Okay, now let's try to check if it is working or not. All right, and also check what is the data type of this. Good, that's what we want. Hive context is not defined, not big deal. We'll just say SQL context, and that's it. What does it say? It says no table called employees. So what we have to do is we have to run the same from the same one where you have copied the conf. Earlier we were using someone else. Bin slash PySpark. Let's try this way. So what exactly are we trying to do? We are trying to connect to Hive, and we had already tested connection to Hive. Now it says connected to Metastore, and it has loaded the table. Now if we say rows.first, then it will give us the data. Alright, where is my data, by the way? Yeah, it will be in the first row. Okay, it will be in the first row, and we could say row.local, and then we could go over what is there. Now you can see that it has brought in the data. All right, two things which we did. One is we copied the conf to this one, PySpark minus help. Okay, so we could have used this properties file, or we could have used this particular this configuration property. All right, and I'm just trying to see how can I specify the config folder. All right, looks like. All right, so basically the important point to remember here is wherever is your Spark installation. Right now we are using this particular installation, okay, because Spark is more like a client here. So in this in this wherever you have unzipped your Spark zip file, you should copy your hive etc hive site.xml into that conf folder. Only then it will run. All right, make sense to you? So this is something important for all of us, right? Now we can put the same thing here as well. All right. All right. So basically you have to run the same Spark in where you have copied your hive site.txt XML. All right. Sounds good to you? Now let's try to create our table here. Let's try to see if it gets created or not. All right, again we are running the same PySpark from which we have copied where we have copied our conf. All right, let's see if it creates or not. By default, if you don't provide any database in Hive, it will create in the default database. Let's see if it has created or not. Select star from src. Yes, if you say drop table src, then the table gets deleted and we can execute again it will be created again. See, it is created again. All right, otherwise it would say that table not found. Okay, you can try drop table and then try selecting. It'll say uh, table not found, but when you create a table from here and say select star, it says 0 records. Okay, like this. All right, now let's try to load our data, and our data was in what folder? Data was in d- dot sgiri spark. Is it there? Yeah. All right, so we can specify the same place of data which we had done. like this. All right. Now try to load this data. If you are from a Hive background, you would know that we can interact with Hive in this manner. Okay, I had sent my command prompt, this PySpark, into background by pressing Ctrl Z. I brought it to the foreground by saying FG. And now let's see what error is it giving. Hive failure output. Invalid method name called alter table with cascade. Okay, so all right, that looks like an error in the compatibilities. File renaming to file this to this. Is it copied? Apps Hive warehouse. Let's see if it has been created in this slash app hive kv.txt. We can check that by saying hadoop fs minus ls. Yes, so the file is being uploaded correctly. It is just that there is a compatibility problems with Hive. We might have to use an older version of Hive to work with that. All right, that is something which we were not aware. Load data local into this path and this table. Let's try to do from the other side. If we bring Hive into front, we say select star from src. Yeah, so the values have been loaded into this file. Okay, and what exactly is there in this file? What exactly is there in this file? And let's say this. Okay, so the values have been loaded correctly from this file into our Hive table. Okay, it is just while loading it back, it's giving a problem. While loading the data back, it's giving some problem. Never mind. Now we can query the data again, just like normal way, from the table. All right. Now this results is what we have right now. You can see the results is a big array of objects where each object is a row. Sounds good? Sounds good to you? So we were able to successfully create a table from Hive and then upload the data into the table, and afterwards we were able to query the data from Hive. All right. All right. So that's how you can talk to the Hive. And sometimes you also want to read or write to MySQL. That also you can easily do. Just that you have to make sure to put your driver in the class path. Okay. That means we will have to exit our prompt here and export. And after that, let's try to create first start our PySpark. All right, PySpark has been started. Okay. Now, if you say f equals to this, so we are basically connecting, basically creating a format, right? So this is basically a data frame reader. And after that, we are creating the driver URL. It will depend on which database are we trying to connect. Right now we are trying to connect MySQL. That's why we are mentioning MySQL. And then this is the host name, this is the port name, and this is my database name. I will show you what exactly are we trying to do. Let's exit from here and go to MySQL. Okay, here there is a table called test. Database called test, in which there is only one table called sales. This is the table from which we are trying to read the data. Okay, now if you have a driver URL, we have defined a driver URL with the database name. Okay. Next is that we are going to provide more options to and connect. So we are saying my f dot driver, f is data frame reader, f is f dot driver, this URL is driver URL, this is my table name, username is root, and password is blank, and then load. So what does it say? No suitable driver found. Okay. This is correct only. All right. Never mind. All right. Why it's not connecting to my host? Have we provided the correct? Oh, you know the problem. You know the problem. The problem is we have not provided the correct location to the driver. We'll have to say, okay, let's just go into where were we? As Giri and Spark. I've also copied this driver into slash data. This is a standard driver which you can find from MySQL's website. It's a standard Java driver. Okay, this is JDBC standard driver which you can find. So you can see here the MySQL connector here. This is the driver we are talking about. All right. Yeah, this is the reason. Okay, because we were trying to find this driver in the other folder. Instead, we could have given the location of this place, and only then it could have worked. Okay. All right, so now it's connecting to the database. All right, so it has brought the data. Now here there are few things you should note. One is that by default everything has been read into data frame. See, this is a data frame. Now, since we have registered it as a table, just like we registered our JSON object, that means we can join the data from different data sources and do all kind of complex churning. Okay, as with the big data, most of our data is in disparate sources. Therefore, these kind of tools come into play where basically utilize we basically utilize the utilize the joining of multiple tables from multiple data sources. All right. So this is how you can connect to JDBC and load the data. All right. So here are few things which we discussed. One is the singular concept called data frame. Data frame is the new form of table in in case of Spark SQL. Using data frame, we do all kinds of churning. Data frames could be loaded from JSON plain text or could be created from RDD. On top of data frame, we could do We could do the churning like normal map reduce. Whatever we could do over RDD, we can do the same thing over the data frame. Also, in case we are very obsessed with SQL, we could use SQL context.sql to execute the queries. But before that, we have to make our data frame available. Before that, we have to make our data frame available to the queries. All right. So data frame can be loaded from various places. Okay. So if I have to draw the diagram, it would be like this. All right. I will say that the data frame is a basic concept. Data frame can be loaded from JSON, Hive. You can translate RDD into this. You can convert text file, paraquet, and many other format you can load as data frame. Okay. So using many format you do that. Now for churning the data frame, there are first is by using usual RDD functions. Okay. The second is by using okay. Second is by using the SQL context dot SQL. Okay. And third is by saying data frame dot filter or data frame dot select etc. So these are data frame operations. So these are the ways it could be you could churn data frame. All right. And this is how you could do a lot of computation. Similarly, please keep in mind that any other um, something like the RDD function itself will produce another RDD. Similarly, the SQL also will produce another data frame. So basically, whenever we do an operation on data frame, it produces the data frame. Okay, sounds good to you? And also data frame could be saved back as JSON, saved back as Hive, saved back as RDD, saved back as text file, and saved back as parakeet. All right. Does this sound complex to you? All right. So that's a general concept about the data frames. All right. All right, there is a question from Ishwar. Thank you for the question, Ishwar. Will there be an impact of changing from different format? No, no. Okay, so anything which happens during these transformations happens through the idea of data frame. So In case any of this translation is not good, only then there is a problem. Okay, because data frame as a concept is good enough. Okay, it doesn't lose any information. Only in these individual translation there could be a minor problem. That too can be very well controlled and solved. Great. All right. So that was about data frames. Any questions on Spark SQL and data frames? All right. All right, so we are on the last topic. After this, we will discuss about the project. And project is actually pretty interesting. The project which we have planned. All right, so let's start with machine learning. Machine learning is also a very interesting concept, and it's probably the current breakthrough and is very very important. All right, and so whenever we talk about big data, we talk about machine learning. Why? Because machine learning makes sense only if data is used. Okay, and most of the big data tools handle the situation where the data is really huge. Also, the another reason why machine learning interacts with big data. The other reason is the complexity, because most of the machine learning tools are complex. Their algorithm is complex. When we say complex, complex means the time complexity as well as the memory complexity both are very high. Meaning it will take long time to finish the computation. And you will understand why. As we go forward, you will understand why does it take so much of computing to do the machine learning. All right, so let's just jump into the Iswar's question is machine learning also includes recommendations. That's correct, Iswar. All right, we will try to go through the concepts and we'll try to run a couple of examples. All right. So today's now the idea is machine learning, and we also go over the graphics lab quickly. All right, what exactly is machine learning? Machine learning is programming computers to optimize the performance using example data or past experience. The way human interprets the data and human understands the situations and remembers it, and in future interprets all of this past experience and tries to solve problem based on that. In the similar way, machines also do that. The most common form of machine learning is probably drawing a line. Okay, I'll show you what do I mean by drawing a line. Let's say I'm given a I'm given a say like this. All right, on we are given this information that on Monday this was the temperature. This on Sunday this was the temperature. All right, and on Monday, Tuesday, Wednesday, and this was the temperature, and this. All right. Now this is the information given to you, and your role is to find out the temperature on this date. What is the temperature on this date? Okay, on this date, what is the temperature? Now what will you do is, in general, as human, what we do is we we take the line, we draw something which goes through these, and would say okay, and draw a line vertical from here, and we'll say okay, this seems to be what you are looking for. This seems to be what you are looking for. All right. So this is prediction. This is the most common form of prediction. Is my voice breaking for all? Jitender is unable to hear. Gaurav is saying it's clear. He can hear. Mehdi can hear. All right. So I'm assuming that. And Ishwar is saying he can sometimes there is a. Ishwar's question is, what is the difference between forecast and prediction? There is no difference with respect to our machine learning. No difference with respect to our machine learning. So this is prediction. We are trying to do the prediction or trying to do the forecast based on the past data. So this is the most common form of prediction. And if we have only 100 points, we can simply draw the graph by hand and be happy about it. All right. So this is also intelligence. This is an intelligence based on past experience. We are trying to predict the future. All right, by converting everything into numbers. Now the situations go really complex. If you have more number of variables, you can visualize that if there are two variables, here there were two variables, x and y. We were trying to predict x based on the past value of x and y. Sometimes you have 20 other variables, say x, y, and z. All right. So let's say instead of this diagram, let's say on x-axis we have input feed, and in an industry this is the produce. This is the output. Okay, on x-axis we have, this is the input feed, this is the produce. Now you can see that on input feed change, as the input feed is increasing slightly, the produce is also increasing. So we were able to do the maths. Now let's say there is one more data that is important when it comes to the. Okay, so let's say there is one more input variable called weather conditions. Now we gathered the relationship between temperature, input data, input feed, as in we are feeding some input crude oil. Let me just put crude oil, and let's say produce. Instead of saying produce, we are saying LPG. So there is a let's say what does okay, petrol. Okay, so there is an industry, there is a factory which produces petrol based on crude oil, Okay, and temperature of a particular furnace or distillation column. Okay, so so the relationship between the petrol and crude oil will be there, as well as temperature and petrol will be there, and therefore we'll have a three column data, in which we will have in first column the crude oil amount. Okay, this is, let's say, crude oil rate, the flow rate of crude oil, and the temperature of distillation column. These are the two variables given, and we were also told about the produce of petrol. Now, now we have to do the prediction based on two variables. Given given crude oil given crude oil rate and temperature, please predict petrol. Or or the problem statement could be, we are given the we are given all this information for 1 year. Now you have to give the temperature of the distillation column when we want this much of petrol output. Okay, so any of the variable could be missing, and your program might have to fill it in, might have to predict it. All right, so generally when the correlation is linear, the linear regression is good. All right, if the correlation is linear, the linear regression is great. But what if the relation is different? What if the relation is logic? You can imagine that. um all right, how to select this? Imagine this. So this is good, this is good if you just have the, let me just save it before I lose everything. All right, so let's say our data was a little awkward, and all right, let's say our data was little awkward, meaning data would have been of this kind, then this, then this, then going up. So it's a sort of a curve. When the equation is not linear, the linear regression or the linear way of solving problem may not work. And most of the time, it doesn't. Therefore, you need more complex algorithms. Something like logistical regression, something like more difficult way of solving things, something like the support vector SVT. And that's where the machine learning comes into play. So the overall general idea is, try to predict we first try to predict what sort of relation is there between our input variables and our various variable. Is it linear, or is it a curve, or is it exponential, or is it something totally unpredictable? It could be really unpredictable, and we need to figure that out. Or sometimes we figure out that out of 500 variables, 30 variables are having no impact and no relation with others, and that's where the study of data sciences start. Okay, so understanding what is the correlation between our data, filling in the missing values, where sometimes the temperature might be missing, sometimes petrol might be missing, and sometimes we want to predict the crude oil rate for our required outcome and the temperature. So basically anything could be missing and we have to fill it in. We might have to predict any of the variables, whether dependent or 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 uh, or the independent variables. Okay, with respect to data science, dependent and independent variables do not make much of a difference. Okay, So we just call the whole thing, the prediction thing, as filling the matrix of the data, because the same thing, whatever we are talking here, could be represented as a three column data. We could say things like, um, we could have we could have things like three column way, as in we have this nice table and there is one, column two, and column one is for temperature, column two is for produce, okay, and I mean the petrol produce, when I say produce it is petrol, and column four might be the flow rate. There could be more and more values, all right. So I'll just put a somewhere, and we are given lot of values, such values, okay. These are a means there is some value given to us. Now next problem could be given some value of this, what exactly is the value, not this, I'll say this, and we might say what is the value of flow rate for some value of petrol, some value of temperature. We might also say that given some value of petrol and some value of flow rate, we want to predict what is the temperature. Okay, so we are given, so this is called, if you look at it closely, it's basically a matrix which we are trying to fill in. All right, so how do we generally do it? General thumb rule is, first, out of the data which is available to us, okay, out of the data which is available to us, we try to create a model. Now we have, so out of this data what we are talking here, out of this data whatever we have here, okay, how do I draw this? Out of this section where we have all the information, we create a model saying that, okay, it may be our linear regression, all right. And then what we do next is we delete some of the values, okay, okay, ouch, all right. So out of the data which is available to us in nice format, it has got many columns, okay, it has got many columns and many rows, okay. So based on this data we try to do the prediction. So based on this we form the prediction, we form our model, and then we try to, we basically create another sort of itself, okay. We remove, delete some values, okay, and then whatever table that comes out, there'll be some table that will come out of this, okay, there'll be some table that will come out of this. Now we will apply, we will we will use we will use whatever model we have developed. Let's say we say that we have developed, it's an LR, as in linear regression, okay, it's a linear regression, and then on the same table we apply the prediction, we predict the values, then we predict the values of this table. There'll be another table with all the values, okay. So we try to predict based on our model, we try to predict, and then we compare these two. This is what we do in the comparison. All right, this and this we compare. So what exactly we did, we had some good data, we prepared a hypothesis, and we deleted some of the values, and then we predicted the deleted values and compared with actual. The one, is our prediction good or bad? Similarly, we try to, and how do we compare a full values? How do we compare the deviation? We generally compare it using root mean square value. And after we compare, we say that okay, this model is good, this model bad, and hence the data is better fitting in logistical, not linear. And this study of data is called this study of data is called linear regression, is called data sciences. Sometimes lot of data is not, we are not able to predict the data behavior. So presentation is also useful in doing the data sciences. But right now there is no great tool for doing the prediction on big data, on the big data. Yes, prediction is done by machine learning both. So machine learning is not a single thing. Machine learning is basically bunch of algorithms which are used for prediction. So prediction, there are multiple format of prediction. So this, whenever we draw something like this, so our main objective is to convert our input data into this matrix of numbers. Whether we are doing the spam filtering or we are simulating a robot, in all cases we try to convert our input and output data into a matrix, into the vector format, and then we start doing the prediction. And that is the role of a data scientist. All right, so it's a branch of AI, design and develop for the design of development of algorithms, and computers evolve their behavior based on empirical data. There are generally three kinds of learning. One is supervised, unsupervised, and semi-supervised. Supervised is given input, we first train the data, we train the models saying this is our input data, prepare your model, and then we ask for this input what is the output. That is supervised, such as training a module, a training an algorithm to with with the visual images of things and saying that this is apple, this is cat, this is table, this is chair, this is, so that is supervised learning. And then asking the algorithm, hey, see this photo, can you tell me what is it? So we create a classifier and then we try to predict output on unseen inputs. All right, unsupervised learning on the other hand is, we are given a data dump, we are given metrics and information, and we are asked to do things like categorization automatically, such as i'm giving you the the information about all the cars in the world. Now you have to prepare a hierarchical charts of saying that these two cars are closer to each other, then these two cars are farther, and so on. Or or given the languages, given the text from all the languages in the world, predict which language is closer to which one. prepare a hierarchy of all the languages of the world, so such that the languages which are closer to each other are closer in the representation. So that's a study of unsupervised learning. That's also called clustering. Semi-supervised learning in some way midway between these two. Probably this will clearly tell you. So this is your labeled data. This is my triangles. This is something. Now separating the two, creating the cluster is called supervised learning. Okay, whereby I have already trained I have already trained the system that hey, this means round, this means rectangle, this means round, this means rectangle, and then whenever I give an object, it will quickly classify it clearly. And semi-supervised learning is based on you don't know the input data, as in you are we have there's a lot of information for which we have not told that whether it's a triangle or a round. Okay, this has to be predicted by the system. There are many applications of machine learning. Anywhere there is a huge data and lot of things has to be predicted, then machine learning could be utilized, specifically if you have huge data. If you don't have huge data, there is no point in talking about machine learning. If you are talking about 1,000 records or 2,000 records, then your problem statement does not qualify for machine learning. Also, it's very important for you to understand that the various machine learning tools available. If you have few lines of data, a whiteboard is great enough for doing the analysis and visualization. If you have few kilobytes of data or megabytes of data, our MATLAB Octave is good enough. But if you have gigabytes of data, then NumPy, SciPy, and these tools are good enough. Now, the moment you hit the gigabytes of data, you have two separate tools for analysis and visualization. But when the data grows beyond lower GBs, if it goes to 10 gigabyte, 20 gigabytes, 100 gigabytes, and so on, then your other tools cannot help. That's where MLlib, SparkR, and GraphX, along with Mahout and Giraffe, comes into play. MLlib, SparkR, and GraphX are the components provided by Spark for machine learning. And also there is no great visualization tool for this kind of data, because you cannot visualize hundreds of gigabytes of data using your computer screen. Therefore it is important to convert the data or trim down the data into few gigabytes to represent it on the screen. All right. So the goal is to so machine learning library MLlib is the library of Spark written on top of your RDDs in order to make the machine learning tasks easier. Okay. It consists of learning algorithms and utilities, and it starts with classification, as in you classify your input data into various buckets by doing the and then doing the filling of a matrix, which is regression. Clustering means unsupervised learning. Collaborative filtering is a kind of classification, is also called recommendation engine. And dimensionality reduction, sometimes you want to remove some of the variables which are just noise and do not have impact on the output. And high level optimization primitives, if you basically there are lots of optimization that goes into machine learning, and MLlib provides those functions. All right, recording is going on. All right, so let's start. So there are two basic packages. One is MLlib, other is MLlib is the original API which is built on top of RDD. Okay, which means it's more raw, it's more crude. While ML is a new next generation high level API built on top of data frames, keeping the data scientists into the mind. And it's great for constructing ML pipeline. But we will focus on MLlib first because ML is still in the development phase. All right. So there are, first of all, the see, most of the data science has been there for more than more than hundreds of years. Okay, Data science came at the time of Taylor series, whereby we started predicting the data at the time of Taylor, which is like 200 years ago. And at that time, a so most of the algorithms have been for quite some time since the invention of maths, right? But lately, when the data and the computing became popular, then the machine learning has become quite popular. Now, what does Spark brings to the table? Spark brings to the table a data structure called RDD. RDD makes it possible to process data using hundreds of computers, which was not possible using any other tool, be it NumPy, be it SciPy, be it be it your R or SAS. None of these tools, none of the data science tool could not go beyond a single computer's RAM. So we ended up buying a lot of supercomputers. We ended up buying a lot of RAM, right? Now, those kind of problems are very well solved by MLlib. Therefore, MLlib has to provide the very basic structures on top of which most of the basic algorithms could be written. The basic structures is vector. Vector is nothing but an array of values, and labeled point, which is point A, and these are the characteristics of the point A. Then matrices, the various kinds of representations of matrices. So one is that all the columns as one object in RDD, and distributed as in ranges of the sections of the matrix into one RDD, one element, and so on. Because matrix at the end of day is represented as RDD internally. So in what way you want to represent it in the RDD in the linear format, it has caused so many representations. All right. Now you can do. I will just go over various things which are possible using Spark, and how are they classified. So once you have this data in place, you can do a lot of magic. So you will have to prepare your data in the form of vectors, labeled point or matrices, and feed to the algorithms. So the kind of algorithms which are available from MLlib is, first is basic statistics. Under basic statistics, you have your summary statistics, something like mean, median, minimum, maximum, and standard deviation, how many standard deviation away from the mean, and so on. Okay. The sampling part, hypothesis testing part. Hypothesis testing as in you have said that okay, this data is, these variables have no impact on the output, and you have to test this hypothesis. So to test this hypothesis, you can use any of the standard tools available. All right. All right. Also, when you say this data has got a bell-shaped curve, you can quickly test that hypothesis using given standard algorithm. Now, to do the random data generation and to do the density estimation, kernel density estimate, there are these standard uh, statistic functions which are available right away. You can utilize those to do lots of basic cleaning up of the data. And although these functions have been forever in other languages, why would you use Spark is because of the data size. All right. So you can try these out. You first prepare you, Spark context, which is there already. Prepare a matrix, and then you feed it here. Now you can do, other than the basic summary statistics, you can go ahead and start the classification and regression. Classification is, there are generally three kinds of classification. One is binary classification, saying yes or no based on certain characteristics. We say that this email is yes or no, email is spam or not. That's binary classification. Using the binary classification is done using linear support vector machines, logistic regression, decision trees, random forests, and uh, Bayes theorems. Then multi-class classification, that this object has got these many properties. Okay, and that is done using logistic regression, decision trees, random forest, and naive bayes. And then the regression is filling the grid with the missing values, and that can be done in many ways. Okay, these are the many algorithms that are available. You can try using any of them. The more details is link is given at the bottom. Now, collaborative filtering is something which is very common and is very commonly used in organizations. What is collaborative filtering? Collaborative filtering is a recommendation engine. Okay, basically, the technique aimed to fill the missing entries in user item association matrix. Given your history of watching movie based on your ratings, you have to predict what what movies you may like. In those cases, in such kind of scenarios, we call it like user item recommendation. And this user item recommendation uses the algorithm here called ALS algorithm. Here is here is an example of how does it work. All right. Now, so we can first I'll just explain to you what's going on here. First, we are loading data and then converting data into something called a rating object. We are first splitting the records by comma and then going over each record and preparing an object called rating with three values, converting those three values into integer. So first is the user ID, movie ID, and the rating. That's what we are preparing here. All right. All right. All right. So let me start. So let's just load the text file. Okay, let's just collect, say, take. All right. So you can see that the data contains strings, comma separated ones. Now all we need to do is we need to break it down first, and then after breaking it down, convert it into ratings. All right. So ratings is this, ratings dot take 10. So rating is not defined. We have to import. All right, now let's try to do it again. You can see that the ratings are now defined, and the first is rating user equals 1, products equals 1, and rating equals 1. So what did we do? Rating is nothing but an extension of a row, and hence it's ready to be converted into the data frame. Okay, we have converted the data into, so you can see rating, what ratings. Okay, so it's basically an RDD in the Python. We have just loaded our data and converted into ratings. All right, now let's say we want to predict the we want to first prepare the model by saying ls.train, and we have to provide it rank and the number of iterations, as in how many times it has to keep on doing it. And okay, so it says again rating is not defined. Why does it say that? All right. All right, so now it's running and doing the recommendation generation. Okay, so this is our model. It's a matrix factorization model which it has prepared, and this is the model which we were talking about. This model will do the prediction for us. All right, let's try to do the prediction. We say now, you see that what we are doing here, we are removing the ratings from our original data. We are removing the ratings from our original data. We are just leaving user ID and movie ID and let the model do the prediction for us. This is where we are doing predict all. We are saying model dot predict all this particular data, as in predict the ratings in this. All right, and then we are saying map, as in run. We are running the map function such that we are breaking the predictions into the three columns. And now let's have a look at the predictions dot take 10. All right, so it has done the prediction for us. All right, it has done the prediction for us, and let's see what was there in ratings dot take 10. And let me just take it out from here, put it here, and you can see this is the ratings for first 10 records, and let's see what is there in this. All right, the order had changed, so it wouldn't make sense to compare one on one. So for user 1, product 1 rating was 5. Do we have a corresponding one? No. Alright, user 1, product 2? No. User 1. Or we can say 4 equals 4. Alright. So we have ratings dot select user equals 2. Alright. User equals to 4 and product equals to 4. Alright, let me do it other way. Dot filter product all right, now let's see what was there. Bool object is not callable. All right, I need to see what exactly could be done. Or maybe we can register it as a temp variable and then query. I'm not great with the data frames yet. All right, so basically or maybe we can just do a filter. All right, we can do it later also. So if we have to just figure out what was that, where is our data? Our data is at this location, right? This is where our data is. Cat this. All right, if we just have to figure out grep 4 comma 4. So the rating was 5.5 originally for 4.4 comma 4, and here we have 4.996. So that's quite close. Okay, and what about 4.1? The rating is 1.0. For 1, the rating was 1.0, and how much here is 1.000. Okay, so the result is quite closer to the original. Now, how do we ensure that it's quite closer to the original? So what we do is we will, after we have prepared the ratings, let's prepare, after we have done the predictions, let's try to join it with the actual one. We are joining the ratings and the predictions together, and then we will do the subtraction. Okay, we are joining the two together, and then we will do the subtraction. Okay, so we have joined ratings. First we took the ratings, whatever we were given, we took converted it into a tuple. Okay, and then we are joining it tuple such that the key is the two columns, right? User ID and item ID, this is the key, and we are joining it with the predictions. Now once we join it with the predictions, the values for this item and this product will come together with the prediction. So actual and the predicted will come together, and then we will do the subtraction here. Okay, after doing the subtraction we'll square it, and then we'll compute the mean, and that's how we will compute how far is this data from the original. It says the root mean square value is this much. You can see that, which is very very small. The mean squared error is 10 to the power minus 6, which means our prediction is very good. What we did was we compared the actual and the predicted, and then subtracted the predicted from the original, squared it, and then found out the average of it divided by total number of records, and that's what is mean squared error, which is very small, and that means our model is brilliant. All right, so you can see that our model is really good, and therefore we can now save this model for future use into this. All right, at later point of time we can load this model, or other users can load this model for real-time predictions. Okay, now this model can be used for prediction. You can use this model for prediction. All right, so in future, as part of this exercise, we did couple of things. First, we did the prediction using we first prepared a model. We prepared a model which is based on the input data. Now, once we have done that, we use this model to predict the output. Once we have done the prediction of the output, we computed the outcome. We compared the outcome with the expected value, and we compared it by computing the mean squared error, and once we were satisfied we saved it into the file, and later point of time we could load it and run the recommendation. All right, sounds interesting to you? So if you can go and have a look at the data from movie lens. Have you used movie lens data before? Movie lens data. Okay, you can download movie lens data from here, and then you can load it in Spark and start predicting. If you don't know what movie to watch, you can basically go through the movies list and give your recommendation, add your user ID, give your movie ratings, and then try to predict the movies for ratings for you, or try to predict the movies for you. You remove the movies and you fill in user ID and movie ID. You fill it with you leave it blank. Okay, and then the ratings, you say that I want the movies which are 4, 5 or something like that. So using that, the recommendations can be prepared really well. Sounds interesting? You can try this out. At least I will go and try it out for myself. All the movie suggestions. So I'll fill in. I will try to predict how good is a movie for me. So I will create a data in which my user ID will be there, my all the movie list will be there against me, and ratings will be missing. And then I'll try to see what will be the predicted ratings. All right. So that was how we do the movie recommendations. All right. Next is clustering. Clustering is also very straightforward process. Given various kinds of points, all you have to do is automatically figure out what groups exist. This looks very obvious, but in reality, this is a complex structure. So clustering is an unsupervised learning. The objective is something like this. Given a matrix of data Given a matrix of data, classify the records into 10 buckets, or 5 buckets, or 3 buckets, or 20 buckets, or 200 buckets. Something like when you look at the email and somebody asks you, can you just classify my emails into 4 buckets so that my life becomes easier? So the similar item should go into a similar bucket. So for clustering, there are many algorithms, and this is what is supported by our Spark. K-means is very straightforward. Then Gaussian mixture, PIC, LDA, and streaming K-means. Streaming K-means as in you have predicted a model for the data to be separated into four buckets. Now, as and when new data is coming in, you want to immediately classify it into one of the buckets. All right. So you can run this k-means example and see for yourself. All right. So there are other classes of algorithms which you can have a look at here. And the I'll just go through one GraphX example. So what exactly is GraphX? GraphX is part of machine learning for the problems which are graphically, which have lot of graph. Graph is a very important data structure, and when the graph grows bigger, it's impossible to put it in the RAM, and therefore you need a system like GraphX, which converts your graph into an RDD, and hence your graph is located on hundreds of machines. All right. So it provides the fundamental operators on graph data structure. What is a graph? Graph has got nodes and graph has got edges. Edges connect one node to another. Edges can be directional, edges can be weighted, edges can be non-directional. So graph can be used for problems like finding path from one city to another. Graph can be used in giving the recommendation of friends. Graph can be very useful in predicting in predicting various kinds of difficult difficult network problems. Now graph has got many use cases, and the basic algorithms which GraphX tries to solve are generally of three kinds, which are difficult, which require lot of computation. Those kind of problems are have been are part of the standard library, such as PageRank. PageRank is how important a page is. It is governed by how many people are linking to it, and so on. If there are a billion pages and they are linking to each other, this definition becomes very complex. And that's how Google does it. So PageRank is one algorithm which GraphX provides. Second is connected components. Giving all your friends and their relations with each other, find out what are the groups amongst your friends automatically. Cluster your friends automatically. That is connected components. Triangle counted, as in given a geographical surface, generally most of the animations are built by um, creating triangles. So generally, to measure how many triangles are passing through a vertical or through a vertices is a triangle counting problem. Okay, though GraphX is only available in Scala yet. This is a quick example of page rank problem. You can try it, and it should give you quick ranks of users. All right. So for this, we will run bin slash spark shell. So we are probably running Scala shell for the first time, and you will be surprised to see that how similar it is. All right, let me just take it out from here, put it in this, and then compute. It's saying, all right, let's try to do graph loader. We need to import graph loader. All right, we can see to that later. All right, so you can have a look at it, how to go about running this. You can have a look at more about graphics. It's a general idea about how you can do the computation. All right. So with the various kinds of algorithms which are under graph, you can have a look at the manual. All right. Now, so we quickly covered the overall thing in MLlib using Python and Spark. Iswa is saying, I think the community develops everything first in Scala as Scala is easy. So the thing is, no matter they are using Scala, but they are ending up, everybody is ending up with Python because Python already has NumPy, SciPy, and everything inbuilt. And therefore, my prediction says that the Python Spark will be the most prominent most prominent as compared to Scala or Java. Java, Spark in Java is not going to be popular because Spark, if you think, is an analytics tool. An analytics tool caters to the people who are from analytics background or from data science background. And most of the data scientists are very comfortable with Python. Reason being, it's easier to code, and other reason is that most of the tools, be it Panda, be it NumPy, be it SciPy, the most prominent data science tools were in Python. All right. Ishwar is saying, but adoption of Python in enterprise is less. But if you look at the thing that Scala's adoption is going to be further less. Therefore, Python is the best bet out of all. All right. And that's the reason I thought over it again and again. Um, Using Scala is not a big deal, right? The more what I wanted was to have the more control and the grip on the concepts, and there should not be any laziness or fear in running things. All right. Now, so that was our quick introduction of MLlib and Spark. All right. All right. So the assignment for a project is I've prepared some data. Yeah, I've prepared some data. You have to uh, first go to HDFS, locate this folder. Okay, locate this folder in HDFS, which is on Hadoop 1 file browser, and we say data spark project. All right. These are the Apache logs, which are from our website. So this is a real life data. This is a real data that is coming from our server. All right. So one is access log, error logs, and other is access logs. Okay. So your objective is to how, find out how many errors have occurred every day. Okay. Second, how many errors have occurred, how many access requests were there every day, then plot them on the graph. Then third, you have to find out is the errors per access request, how many errors were there per access request that came from the user. All right. So if you look at this data, this is access logs. Okay. Access log, everything is zipped, so your objective is to clean that. Okay, because 90%, 99% of the work in anybody's life is to cleaning the data, reading the data. And look at this. This is the line of this access log begins with a timestamp. See this timestamp? This is the timestamp, this is the IP of the user, and people are, these are the URL that has come from the user. Okay, this data is confidential, do not make it public. All right, since you are a student, that's why I'm sharing it with you. This is our website's data. All right, do not make it public to anybody. Now this is the IP address and the date. So these are the individual records that there's a request that came at this point of time, there's a request that came at this point of, and so on. All right. And this kind of data is there for maybe for there are hundreds of items. Okay, although these look very small, but when you unzip this it will be really big because it's a plain text. All right. Similarly, there are errors that have occurred on the server. All right, there are errors that have occurred on the server. And so let's take this particular error. It says that it starts with the timestamp, with the date, and then there is an error message. All right. So basically, you given these kind of errors in the history, you have to count total number of errors. All right. At this time, this error, this time, this error. So you have to compute it on the basis of time. All right. So given these errors and access requests, you have to compute these three things. All right. Is the question clear to everyone? Yes. Please submit this by the end of this week. All right. By before the next Saturday, please submit this. All right. So that's pretty much. And I'll be adding more and more assignment to this, and we'll be sending you the email with the assignments. All right. All right. Thank you, Ishwar. Thank you, Gaurav. Thank you, Jitender. Thank you, Mehdi. I hope you liked the session, although we are running late by 30 minutes. All right. But the plans are a bit changed. We planned to put more machine learning, and we plan to extend the loading data and saving data a little bit more? All right. All right. Have a good day. If you have any problems, any questions, feel free to reach out to us at reach us at Novik Data. And if you have any questions directly to me, you can write to Sandeep at novikdata.com. All right. Have a good day. Bye bye.